Today we're talking about servo drives for mobile robots and cobots. So I'm going to start with a quick introduction. Mobile robots can be used pretty much anywhere, but we're seeing exceptional growth in automated warehouses where AGVs are used to fulfill online orders, in hospitals, for example, pharmaceuticals. This is where a robot stores and transports medication to a patient's room in the hospital. Also in hospitals as service bots where they do laundry delivery, or even at grocery stores and airports for automated floor cleaners. Also in grocery stores and big box stores, mobile robots are used for tracking inventory. Cobots or collaborative robots take the shape of an arm and are usually mounted to a fixed location, but they can also be mounted to a mobile platform, which allows them to move and work where needed. Cobots work in close proximity to people and other robots. They're designed to be versatile so they can handle a multitude of repetitive tasks like moving, sorting, packing, and assembly. In both mobile robot and cobot applications, for every axis of motion, there needs to be a motor to drive it. And to drive each motor with precision, there needs to be a servo drive to supply the power and motion control. This means for every traction wheel on an AGV, or every degree of freedom on a robot arm, there needs to be a servo drive. But, regardless of the different applications and different jobs for each axis, when it comes to the servo drives that power them, mobile robots and cobot applications have a lot of requirements in common. So even if the application looks different on the surface, the requirements for the servo drives are actually similar. So what are the requirements for cobots and mobile robots, and how does AMC fit in? First of all, we have 220 standard off-the-shelf servo drives to choose from. Within this group are a lot of great choices. So I'm going to break this down into the attributes that are important for cobots and robots. With regard to voltage, compared to traditional factory applications, mobile robots and cobots operate with a relatively low DC supply voltage, typically in the range of 10 to 100 volts DC. This is mostly due to the availability of batteries and safety, although higher voltage systems also exist, for example with industrial robots and agricultural robots. In the low voltage category, our standard products operate over a wide range. For example, 10 to 55 volts, 20 to 80 volts, and 40 to 175 volts DC are typical operating voltage ranges for our products. The benefit of wide ranges is especially important with battery applications because the difference between a fully charged battery at the beginning of a shift versus a drained battery at the end can be pretty big. And regardless of what the input voltage is, the servo drive performance should remain the same throughout the range, meaning the responsiveness needs to be the same as well as the torque output and tuning, although admittedly the top speed may suffer when the voltage is low. Almost everyone wants more torque, which really means they need more current. Anywhere from 5 amps to 100 amps is a typical requirement and can easily be satisfied with our standard product offering. Even higher currents are available with some of our products like our vehicle mount drives. High current output is needed for axes like traction wheels on an AGV or the base joints on a robot arm. Efficiency plays a critical role when batteries are the source of power. The higher the efficiency, the less wasted energy. This means robots can run longer because their batteries last longer. At AMC, all of our products use some form of PWM switching, which makes them inherently efficient. Our products are not only known for their high power, but their high power density. In simple terms, high power density means increasing the amount of power per volume. If you provide the same amount of power but in a smaller package, then you've increased the power density. For example, these two servo drives can output about the same amount of power, but this one has much higher power density since it is so much smaller. The advantage of high power density is it makes it easier to fit more power into a smaller space, an extremely important consideration in AGVs and robotic arms. Also, with the smaller physical size comes reduced weight. Every gram of mass saved increases the payload capacity. The reduction in dead weight also helps with overall system efficiency because there's less weight to move around, accelerate, or lift.